Our next algebra lesson is called Polynomials Addition. Our goal is to simplify polynomials by adding like terms. Look at your vocabulary words. I'm going to read the definition and say the word. I want you to repeat the word after me. A term containing no variables is a constant term. A term that has the same variable as another term, including the same exponent with each variable, are like terms. A number or a variable or an indicated product of a number and variable is a term. Okay, in this unit, we will look at an algebraic expression called a polynomial. Polynomials have variables with positive integer exponents. The best way to understand polynomials is to look at some examples. Then we will learn how to find their sums, differences, products, and quotients. Be sure you understand the definition of a like term in the vocabulary. We will refer to them as variables and constants. What is a term? A term can be a lone constant, or a variable by itself can be a term. A term can be a product of constant and variable. A term can have more than one variable, and the variables can have any exponent and still be a single term. Since division can be expressed as a product by multiplying the opposite, fractions or indicated division that does not include addition or subtraction constitutes a single term. Okay. So let's look at this. Basically, the easiest way for me to describe this to you is if I have xy plus 0.3 minus 7a terms is anything combined by a plus or minus sign. Okay? So this is xy is a term. 0.3 is a term, negative 7a is a term, okay? If they're multiplied or divided, that's fine. They're still considered one term. Okay, for example, now let's talk about like terms. Like terms have the same variables. Remember, a variable is a letter. Okay, so if I have 2x plus 7x minus 1,000, 1x, just look at the letters. Look at the variables. They all have x, so these are like terms. Alright, how many terms are there? Let's count them. Remember, a term is anything combined by a plus or minus sign. So there's 1, 2, 3. That has 3 terms. And they are like terms because they have the same variable. Right? Also, to be like terms, they have to have the same exponent. If this is x squared, then this doesn't have this is not a like term to that. These two are like terms. They both end in x. This is not a like term because it is x squared. Okay? That's all this is saying. Let's go to number 1. Let's go ahead and go to show problems. Look at number 1. 6a and negative 60a are like terms. Let's look at it. 6a and negative 60a are like terms. Remember, we only look at the variable. They both have a, so they are like terms. The constants don't matter. The coefficients don't matter. The numbers, remember, the numbers are the constant or the coefficient. It doesn't matter what they are. As long as the letters are the same, as long as the variables are the same, they're like terms. So number 1 is true. Let's go to number 3. Let me write it down. We have a cubed b squared c. We have a cubed b c squared. And we have a squared b cubed c. Are these like terms? In order for them to be like terms, they have to have the same exponents. Look at the a. This is a cubed, that's a cubed, this one is not. This is a squared, so it's automatically false. I don't even have to look at anything else. All of them, all the exponents have to be exactly the same for them to be like terms. See, this is b squared, that's b and that's b cubed, so those aren't the same. C squared, c, those aren't the same. In order for them to be like terms, all of the variables have to be exactly the same. Even if this was cubed, they still wouldn't be like terms because the b's are different. Even if the c's were the same, since the b's are different, those are not like terms. Okay? So number 3 is false. Let's look at number 5. We have 1/3 mn 0.58 mn and -4 mn. Are these like terms? What do you think? Remember, look at the variables. All of these variables are exactly the same, mn. So these are like terms. It doesn't matter what the numbers are, as long as the variables are exactly the same. Okay, let's go to number 7. (7k) minus 2k and -1/5 k are like terms. What do you think? You should have said they are like terms because look at the variables. They're all k's. That's all that matters. They're like terms. Okay, let's look at page 2. Now we're going to talk about addition of polynomials. The first operation to be considered is addition. In this section, you will learn to add like terms within polynomials. The associative, commutative, and distributive properties are used to add like terms. Okay. We talked about the distributive property. Remember, AB plus AC equals, if I take if I divide both of these by A, this is what's left, B plus C. B plus C. Okay? And if I multiply this, A times B is AB, plus A times C is AC, then I'm going to get that all over again. Okay? So this is the distributive property. We discussed that before. Look at your vocabulary words. I'm going to read the definition and say the word. I want you to repeat the word after me. The numerical part of a term is a coefficient. Notice in the examples that the answer is obtained by adding the numerical parts of the like terms, and then by arranging the sum and the common variables of a product. Follow this procedure to add polynomials. Alright, let's go to number 9. If I have 7y plus 2y, I add the numbers as long as they're like terms. These are like terms. 7 plus 2 is 9, y. Okay? And you've done this before. This isn't anything new. Go to number 11. Okay. I want you to try to do number 11 and then compare it with mine. Okay, so stop the tape and do number 11 and then compare it with mine. Alright, let's look at it. We have minus 4m plus 3m plus negative 2m. Are these like terms? They all have m, so yes they are. Okay, if I have a plus and minus together, I just get rid of the plus, just get rid of the parentheses, there we go. Ouch. Okay, so negative 4 plus 3, my signs are different, so I subtract and use the sign of the larger number. My larger number is 4, so my answer is negative. Negative 1, I have minus 2m, so what is negative? My signs are the same, so I add. 1 plus 2 is 3, so you should have came up with negative 3m. How'd you do? Okay, go to number 13. I want you to stop the tape and answer number 13, and then I want you to check it with mine. Okay? So stop the tape and do number 13. Okay, let's see how we did. Okay, these are like terms. Alright. So, first thing I'm going to do is get rid of the parentheses. The opposite of 1/6 is negative 1/6 xy. If I have a plus and minus together, I just get rid of the plus sign, but I'm going to do this up and down. Minus 2/3 xy. Okay. Now, in order to do this, I need common denominators. Did you remember to get common denominators? I hope so. Okay. I have 6 is 2 times 3. My other one is 3. 3 times 1. The 3's are the same. So I take whatever, one number times whatever's not circled on the other number. 6 times 1 is 6. 3 times 2 is 6. So my common denominator is going to be 6. Okay. This denominator is already 6. I'm going to change this to a 6. So 2 times 3 is 6. So 2 times 2 is 4. And of course, don't forget my xy. My signs are the same, so I keep the sign and add. 1 plus 4 is 5. My denominator is 6. How did you do? I hope you remembered that. Okay, let's try another one. I want you to go to number 15. Stop the tape and do number 15, and then I want you to listen to the tape and check it with mine, okay? So go ahead and do number 15. Okay, let's look at it. Negative 7 plus 3, my signs are different. I subtract and use the sign of the larger number. So negative 4. So this was negative 4. Negative 4 plus 2, my signs are different. So I subtract and use the sign of the larger number. 4 is larger, so my answer is negative. 4 minus 2 is 2. A, B, C. Okay? and review that lesson and finish this lesson.